Hello and welcome to Science Unscripted. It's Connor here.
And Gabe, and I've got my phone out here, Connor. And I'm trying to get the pronunciation of... Well, that's part of it.
Okay.
Sorry. I'm trying to get the pronunciation of Kingiri Hai Na Kwa Hok. We got an email, from Vietnam, from someone from Vietnam named Lam.
And real quick, this is one of the joys, or the happiest thing that can happen to us doing this show is a new email from a new voice from somewhere we didn't necessarily expect.
Totally. And he just wanted to say that he likes our voices. He's not a sucker for science, to use his words here, but he likes listening to us talk about science because even the topics that are boring to him, he likes listening to them and even laughs a little bit. And thank you so much. Really.
Yeah, thank you, Lam, and to all of our listeners out there in places again that we wouldn't necessarily expect. That's the beauty of the digitized world, I guess. That somebody in a country that doesn't speak English predominantly necessarily is getting this and enjoying it.
Yeah.
And taking the time to write us about that.
And he said, "Excuse me at the end if my English is not good. I'm not. Your English was wonderful, Lam."
Yeah.
And God.
Yeah, thank you.
How awesome that you wrote to us.
Thank you. I'm just going to hop into an email that sent me down into some more research. And this was, once again, in connection to the fertility topic we talked about a couple weeks back now. The fact that in developed countries around the world, industrialized countries around the world, that fertility rates have dropped below replacement. So the average couple is having fewer than 2.1 babies that would replace our population. It's lower than that. Here in Germany, the number is about 1.35. And how there's an argument to be made that if you want to protect the places that have gender equality over the long term, then you have to look at that and talk about that and say, how do we change that positively? Because the places, there's a strong correlation between the places that have gender equality and falling birth rates, which means those places, population-wise, will shrink over time. And if you go all the way to the end of the generational data, will shrink to almost to vanishing.
That's right. Yeah.
And that's the extreme argument. There are a lot of factors at play. There's a lot of nuance, and that's what these new studies get into. And the email says, "Hey, Connor and Gabe, just to follow up to an email from a week earlier, I read in the newspaper that there's a correlation between the reduction in birth rate in the U.S. and the introduction of," and you're welcome to wonder what it is, the introduction of the iPhone. The iPhone. I expect you'll want to check it out. So that's very specific. And I clicked in, and I have to give credit to where it's due. This is Sabrina Tavernese. She's an author for the New York Times. If you want to look up the article yourself, Why Are Birth Rates Down? 2 new studies point to phones. And so I went into those studies. I'm not going to spend much time with them at all. They do 2 different things. The first one looks at the very specific parts of the United States only where when the iPhone was first introduced, a telecommunications company called AT&T, they were the only ones carrying the iPhone.
Yeah.
Or providing the cellular data for that iPhone.
If you wanted to use an iPhone, you had to do it through AT&T.
Right. And so if you weren't in an area that had AT&T coverage, then you probably didn't have the iPhone, right? Otherwise, you'd be locked into...
Well, you wouldn't be able to use it. You might have had the object, but you...
Wi-Fi. You could use it for Wi-Fi, but in terms of cellular...
Gotcha.
Yeah, most people... Anyway.
And they were looking at the birth rates in these 2 different places, with iPhones and without.
Correct. And by the way, the coverage was really somewhat limited, strongly limited, up from the introduction of the iPhone in 2007 up till 2011. So there's a long period where they're looking at, and what they see there in their data is that this led to a reduction in births among 15 to 19-year-olds of roughly 4.5% to 8%. And the higher you go in the age group, the less significant this effect is. And it's most significant in teenagers between the ages of 15 and 19 years old. And some of you might say, great, let's give them all iPhones. We don't need 15 to 19-year-olds having children necessarily. That's a different debate. But this... I think the safest thing you can say here is this appears to be a part of the puzzle. with regard to falling birth rates. And the reason I can say that with some confidence is that the second study looked at global coverage, roughly 130 countries. And because you can't go to any single one telecommunications carrier, you're looking at like, when did smartphones happen there? And that second study, called The Collapse of Teen Fertility in the Digital Era, also saw a drop in reproductivity once that happened. Okay. So this appears to have an effect because, and I'll quote the author of that second study, or one of the authors, they said, once enough teens are on the phone, being on the phone is where the peer network is. In-person time falls sharply, and with it, the unstructured contact in which most unintended teen conceptions occur. Again, you can debate whether or not those, how good those are in the first place, but that would be one part of the story of the global drop in fertility rates. And I thought that was worth looking into. And again, the collapse of teen fertility in the digital era, and the first one I was referencing about the US specifically, is the iPhone birth control. Causal evidence from AT&T's 2007 to 2011 carrier monopoly. They use causal there because they're kind of applying the gold standard of isolating one very specific variable. But again, difficult to say that, I think, with finality. Anyway.
And that was an email from?
That was an email from Rayfield.
So
thank you.
Thank you very much, Rayfield. Thank you, Lam. We're going to go now to birds, a specific kind of bird.
It's arguably a bird that you're most familiar with in your life, possibly, especially if you live close to urban areas.
We had a long interview, or we're gonna air a long interview on pigeons. You may have heard of this study, depending on where you are. Our CBC listeners, I think they aired an interview on this very topic.
Well, it's that important. It's one of the biggest studies to have been published in the last couple of weeks, and it happens to be from our literal backyard here.
And it's about a bird I almost hit coming into work.
On your bike?
On my bike. It's a bird you're definitely going to know about. But first, a little music break.
So we are back in studio now, Gabe and I, and we are joined by Clivia here in studio. First of all, thank you for coming in today.
Thanks for having me.
Clivia, you have just published research that has gotten a lot of attention all around the world, but why don't we start by introducing you, or having you introduce yourself to our listeners?
Sure. So I'm Clivia Lisowski. I'm a cell biologist by training, but I'm working in immunology here at the University of Bonn and the University Hospital of Bonn.
And you took a big, long look at pigeons recently and discovered something that I think is completely novel, as I understand it. What was it that you found out about pigeons?
So put it in one sentence, we found out that pigeons need particular immune cells in the liver to navigate along the Earth's magnetic field. So usually pigeons use the sun for finding direction. But when the sun is covered, or birds have to fly during the night, or move in dark environments, they need to rely on Earth's magnetic field. And everyone knows that, but nobody knows how animals do that. And now we figured out that apparently immune cells in the liver are essential to do that.
I think there are two pieces of surprising information there. One is the liver, which is not the organ that would have, come to mind for me personally. If you're going to have an organ that helps you navigate, I would have thought the brain, not the liver. So maybe we start there. What is special about the liver in this case that is allowing a pigeon to use or feel the Earth's magnetic field?
I think until now, nobody ever looked at the liver and nobody suspected immune cells to be involved. So previous theories suspected particular light-sensitive molecules in the eye, or little magnetite particles in the beak, and or the brain itself somehow to sense Earth's magnetic field. But nobody ever looked at other cells, and we did. And we found out by a special flight experiment that we did that these immune cells in the liver are essential. And this is completely new, and nobody expected immune cells to be involved in sensing Earth's magnetic field, and nobody expected the liver to play a role in navigation.
And how did you find this out? What was the flight experiment that you guys did?
We choose particular days where pigeons need to rely on Earth's magnetic field, which means we choose days where there's complete overcast, there was fog all over, so the pigeons had no other chance, for example, using the sun or landmarks or any other information.
So, but like a normal day here in the Rhineland is what you're talking.
Oh, you mean from October to April? That must have been really hard to find that day.
Yeah, well, our pigeons were flying at the lake near Lake Constance.
Oh, okay, yeah,
So
down south. Yeah.
They usually and as I said, so usually they use the sun as a primary solar cue to find their way or to find direction. And we choose particular days so that they have no other chance but use Earth's magnetic field. And then we separated our pigeons in two groups. One control group, they were flying fine. They were trained to go 20 kilometers from west to east. And the second group we treated with a particular drug that depletes macrophages for a couple of days. And then we let them fly, same conditions, and they were completely lost. They didn't find their direction. They flew kilometers away, wrong direction. So only like after 24 hours, when the sun reappeared, the pigeons found their way home.
I was going to ask that part, if you got those pigeons back somehow.
Yeah. So, I mean, we found them in spots near their actual loft, but only when the sun came out, they came back. And we also figured we did another control where we depleted macrophages in pigeons and let them fly under sunny conditions. And then they were using the sun as a normal cue. So there were no health issues or any other like general issues with the pigeons. It's only that when they are forced to use magnetic fields, then without the pigeons, they are lost.
So let's go to you give them a drug, a medication that depletes the macrophages in their liver. Can you explain at a biomolecular level what is happening there?
Yeah, so the drug is called chloronate liposomes. It's a very common drug that is used in immunology to investigate the function of macrophages. And it's not specific for liver macrophages. So it depletes macrophages all over the body. But we previously figured out that the main source of magnetic sensing is in the liver, in the pigeons. And so we used this drug, and we used an administration route and a time frame, which kind of narrows it down that the drug targets really liver and splenic macrophages. And then the macrophages basically eat these little lipid droplets. And then due to eating these lipid droplets, they they are killed. And so for 2 to 3 days, these macrophages are gone. And then the body regenerates these macrophages, and the pigeons are fine again.
And when these macrophages are gone, why can't the pigeon recognize the magnetic field? Or what does that feel like to that bird that makes it not able to fly the way it would if those macrophages were there?
Yeah, so that's a great question, because we are still not 100% sure how this works on a molecular level. We know that these macrophages are in the liver lying in close contact or in direct contact to nerve fibers. So what we think is happening when these macrophages are there, we know they contain iron. And this iron is usually not magnetic unless you put the pigeons into a magnetic field. Then these internal spin electrons inside these little iron atoms are aligning according to this magnetic field that is applied. And then these macrophages somehow change their constitution. We don't know exactly. This will be future research. And then this information is given to the nerve fibers, we assume. And then the nerve fibers transmit this information to the brain, and then the pigeon can decide. Yeah. Go east, west, north.
Yeah.
And I know this is beyond the realm of what we can know, but kind of doubling up on Gabe's question, what would that feel like, right? Like, is there anything that's analogous to us human beings? I'm trying to think where maybe if I closed my eyes, I can still feel kind of on my back where the sun is. Is it something like that? How, as a pigeon, how would you feel a magnetic field?
Yeah, it's very hard for us humans to imagine, because we do not, as we know until now, we do not have this magnetic sense. We have this hearing, smelling, everything. But we think it's some kind of gut feeling, really, that maybe humans can relate to this gut feeling. And we know that the nerval innervation of the liver is mainly done by, for example, the vagus nerve that people might have heard of. So the connection between the macrophages and this vagus nerve would allow a non-conscious information transmission. So it's not that you are consciously feel something, but it's rather like a gut feeling, and then your unconscious, this information is unconsciously processed in your brain, and then you feel that you need to go left or right, or the pigeon has to fly left or right.
And this is a unique ability of pigeons to be able to feel this, or is there any other species in the animal kingdom that can do this? Or?
Yeah, actually it's a lot. So we know from a lot of different species that they can use the Earth magnetic field. Pigeons are good, or birds in general are good to study, because you can really see, and we can put GPS trackers on them and we can follow their flights. But we know that there's deep sea sharks, bats, bees, all kinds of animals use Earth magnetic field, but nobody knows how. And now we think it's a general mechanism that we detected, because a lot of animals have livers, a lot of animals have macrophages, a lot of animals have red blood cells containing iron that is then stored later on in these macrophages. And so we think this is actually a mechanism that could explain how particularly animals living in dark environments are able to navigate. And also a lot of, if you think of all the birds that are, twice a year, 5 million birds are going south and north and vice versa. And they are usually flying during the night. So they do not have the sunshine. So they need to somehow have a light-independent mechanism to sense Earth's magnetic field. And this could be a general mechanism. And so now we are thinking about investigating all kinds of animal species. Yeah.
And is this a true first? This is the first time that we understand the mechanism through which an animal would be using the magnetic field. I know the animals you listed before. I've heard those lists before, that there are animals that can do this, which of course makes sense, because if you're going to travel hundreds or thousands of kilometers and you don't have a map that you can unfold, or a GPS smartphone, you need something, right?
Yeah.
So they have something. But is this the first time that we know what that something is?
So there have been theories out there. So, for example, light-sensitive cryptochromes in the eye. But again, light-sensitive already tells you need light. But if you're traveling during the night, or if you're living in deep sea where there is no sunshine, there must be a different mechanism. And now we propose a new mechanism that could be relevant for all these animals, yes.
So it is the first.
Yeah.
A very humble way of saying that.
What led to this experiment? Was it a theory that one of you guys had, and then you said, I'm going to test it? Or for our listeners out there, how did you start to make this discovery?
Yeah, this was actually a lucky coincidence, pure serendipity. So it was my professor, Christian Kurz, director of the Institute for Immunology here in Bonn, and Professor Martin Michalski, the director of the Max Planck Institute for Animal Behavior. They met roughly 10 years ago, when they were invited to the Leopoldina, the German Academy of Sciences. And usually they would never meet on any conference, because research fields are completely apart. But since they met on this Leopoldina meeting, they were talking over coffee. What are you doing? What are you doing? And Martin was telling Christian about this ongoing mystery of how animals sense Earth's magnetic field. And then Christian told him, you know what? I just published a paper where we found that superparamagnetic cells in the spleen of mice contaminate our immunological assays that we usually do. And then they were looking at each other and they were like, oh, wait, maybe these kind of superparamagnetic cells are also available or present in the pigeon. And yeah, then they had this idea. And a couple of years later, I joined Christian's lab. And as I said, by training, I'm a cell biologist. So I'm interested in how cells sense their environment, how they communicate. And when he told me about this idea, I was captivated, and I was like, okay, let's go for it, just test. And then we started.
That makes me wonder again, though, why would mice have that at all? Because we humans don't have this ability.
We do. So we do not have this magnetic sense, but we have the same kind of macrophages in our spleen. So we know that in humans, in horse, in mice, so in all mammals, there are particular iron storing macrophages. And this is due to the fact, so macrophages in general are immune cells able to defend us against pathogens like bacteria, viruses, but also they degrade and remove debris, dead cells, old cells. And these macrophages are specialized macrophages to degrade red blood cells. And red blood cells contain hemoglobin, and hemoglobin contains iron. And iron is too valuable to be lost. And so these macrophages degrade old red blood cells, store the iron, and then whenever new red blood cells should be developed in the bone marrow, these macrophages release the stored iron so that it can be reused. And we know that in mammals, in spleen, these specialized macrophages are located. And so when we started with our experiments, we actually also suspected the spleen of the pigeons to be the location. But then, it turned out that actually in pigeons, apparently, these macrophages are located in the liver.
And could that be a fundamental difference, that if I have these macrophages devouring up hemoglobin and getting super rich in iron as a result, but they're in my spleen, that they don't connect to the nerves that would send signals to my brain that this is right, left, or northwest, south, or east. And then if there's evolutionary pressure because we're traveling long distances and I need this magnetic field, that it slowly switches over to the liver? I'm really speculating, but
Absolutely, yeah. I can also only speculate on this, but probably yes. At some point humans settled down, and the need to, have this inner compass to find direction is probably no evolutionary advantage anymore. So maybe it didn't continue to develop. Whereas, for example, we know also that pigeons have the iron content in pigeon liver is 6 times higher than the iron content in chicken. And chicken are not migrating. Chicken are staying wherever they are, whereas pigeons are flying. So we can speculate, yes, that having this magnetic sense in the liver is an evolutionary advantage. Yeah. And we know also, by the way, that in case humans, due to, some accident or so, the spleen needs to be removed, liver macrophages are able to take over this function. So there is a kind of backup system in humans and also in mice. So maybe it's a different way of evolutionary development.
And if a pigeon has a liver that has 6 times more iron than a chicken, then a goose probably does too, roughly? Is that why we I was going to say worship goose liver, but it's considered a delicacy. It's a controversial one, right? But that it would be a rich source of iron. This is probably why some mammals would choose to eat a liver. I'm guessing wildly here.
Yeah, I don't know. I don't know the iron content of goose, but if it's higher, maybe yes.
I don't know the iron content of a goose liver.
Oh, you don't know that, Gabe?
To be honest. Oh, you guys were both looking at me, and I was like, what am I supposed to do now? We always try to end our interviews with takeaways or something that can make the day of the people listening to the show, that make their day better. I'm just wondering, is there a takeaway for somebody listening to this right now in Canada or in Hawaii or in Antarctica,
South Africa, Australia?
And we got an email from the Philippines.
No, from Vietnam.
From Vietnam.
Yeah, we got a listener who went back through episode after episode saying how much.
Oh, nice! Wow.
How much he loved what we were doing. Yeah, for all of them out there. Yeah, that's a good question. What do they take away from this?
What should they take? Yeah.
Have more respect for pigeons, and because they are very smart birds. And for us as scientists, the takeaway would be that new research fields are open, and then maybe we have to dig deeper into animal behavior. We made a big progress or a big step towards understanding animal behavior. And also for us immunologists, it opens up a completely new field, because we are already understanding that the immune system is not just a few cells killing pathogens, but it's a sensory organ. And here in Bonn, we have this cluster of scientists which are called immunosensation. So we are already understanding that the immune system is our connection to the environment, and that it can sense the environment, and people should take more care of how they take care of their immune system, and what they eat, what they drink, and how they sense the environment. And it could be interesting and a step towards understanding this kind of gut feeling that we have.
One background question that I've never really thought to even wonder about is this, something I've taken for granted, the idea of a carrier pigeon, and that at least in the First World War, possibly up into the Second World War, I don't know, but where these animals were used to transport information from point A to point B and then fly back. How do you train that? Do you know how that even works? How do you start the process of teaching a bird, this is where we are starting, and that 50 miles away is where I want you to go, and then I want you to come back. How does that work? Do you know how that works?
Yeah, so what Martin and his group did, so they have this pigeon and you have to, then they bring the pigeons like 1 kilometer away, let them fly back 2 kilometers. And so like you extend the way they have to find back, and you have to make this home very attractive. Super good food, interesting mates, male, female pigeons. So it has to be very attractive so that they want to come back. And then you just extend the kilometers, you let them start and fly, and it's a training. And for our pigeons, we had 10 training flights so that they know that, okay, I'm roughly 20 kilometers west, and I have to fly east to find my loft. And yeah, this is how. And people have done it like not only in the First World War, but already like it's known for old ancient Egyptian times, or in the Roman Empire, pigeons have been used to deliver messages. Yeah.
You learned from this study, I think, the most important thing one could learn about pigeons. This is truly novel, but along the way, either from Martin or Kurt or whoever, what else did you find out or learn about these animals that all of us have if not an intimate connection with, we have a strong opinion about pigeons? You either love them or hate them. Do you love them more, hate them more? What did you learn about them?
I mean, so I know that a lot of people call pigeons rats of the air and stuff, but it's not justified. I mean, they are very, very smart animals. I mean, it's not only finding direction and delivering messages, but they even have kind of a very basic fundamental understanding of consciousness. So if you look into the mirror and you put a red dot on the pigeon, it will recognize that it sees itself in the mirror. So this is a very intelligent, according to our definition, intelligent way of sensing or understanding themselves. And they are able to detect patterns, and they're very smart. And all these dirty pigeons that we see on the streets, I mean, this is actually due to the fact that humans took pigeons and used them and then did not take care of them anymore. So it's basically our human fault that we have all these pigeons around, and we should respect pigeons much more because they are very, very smart animals.
So it's our fault that they're such scavengers? Is that what you're trying to say? Because the way I understand a pigeon, why they're so big and, if I can use the word, fat. Because I was biking into work today and almost hit one because it takes them so long to move out of the way. It's like they're carrying around three times too much weight, and that's our fault.
Well, I mean, it's like, previously there were wolves, and now I don't know the English word, so now we have the dogs,
The domestication.
The domestication, exactly. Yeah. And so pigeons also were wild animals, and humans domesticated them. And then at some point, did not take care anymore, and now we have all these pigeons sitting around here. But actually, they are very, very smart pigeons.
Well, that's about all the questions we have, or that we should even ask. And thank you for entertaining all of them. Yeah.
Thanks for the interest. Yeah.
But if you guys have any more out there, any questions about pigeons, we could forward them on to
Sure.
Clevia.
Yeah, or the team, yeah.
Or the team.
Sure.
Because there are a lot. This is probably, I'm just going to go out and say it, that the bird that the largest number of human beings on planet Earth has the most intimate daily interactions with. I'm just asserting that out of a gut feeling, speaking of gut feelings, but as much as I like other birds that, Gabe, you might see up in the forest close to the Rhine, you don't really come into close contact with them. And pigeons are special.
Mm-hmm. They are.
Science Unscripted.
DW Made for minds.